see the pressure, how to find out the pressure in a pipe at various sections. That is at the section 2. So what are the data they have given is water is flowing through a pipe having a diameter of 20 centimeter and 10 centimeter at section 1 and section 2. Okay, at section 1 the diameter given is, the given data is at section 1 diameter is equal to 20 centimeter and at section 2 the diameter is given as 10 centimeter. Okay, D1 and D2 are given. Okay, so what are the other things is given is the rate of flow through the pipe is given as 35 liters per second. Okay, this the rate of flow. Q what we have given is 35 liters per second, which is equal to 35 divided by 1000 will get 0.035 meter cube per second. Okay, the rate of discharge at both the sections, section 1 and section 2 will be given as 35 liters per second. We are converting them into meter cube per second. Okay, so then what is given as the section 1 is 6 meter above datum and section 2 is 4 meter above datum. Okay, what is given as Z1 is equal to 6 meter and Z2 is equal to given as 4 meter. Okay, then what they have given, if the pressure at section 1 is 39.24 Newton per centimeter square, that is P1 is equal to 39.24 Newton per centimeter square. It is given us in centimeter, so we can convert it into meter square. So 39.24 into 10 to the power of 4 Newton per meter square. Okay, what they are asked to find out the intensity of pressure at section 2. We need to find out the P2 value. Okay, P2 we need to find out. So what we have to do? We have to apply Bernoulli'S equation. So P1 by rho G plus V1 squared by 2G plus Z1 is equal to P2 by rho G plus V2 squared by 2G plus Z2. Okay, when we see, we know that the P1 value is given it as 39.24 in 10 to the power of 4 Newton per meter square. We know it is a water. The density of water is 1000. G value is 9.81, we already know. But V1 squared, this V1 is not given. We need to find out. But for finding out the V1, they have given us diameter and also the Q. Okay, same way G we know. Z1 is given as 6 meter. In the same way, we need to find out the P2 value. So here also the water is flowing. Rho is density of water. G acceleration due to gravity. V2 also we doesn't know. Instead of V2 they are given as diameter and also the discharge. So first we need to find out the V1, V2 and Z2 is given as 4 meter per second. Okay, so first we need to find out that V1 is equal to V1 is equal to Q by A1. Q1 is given as 0.035. A1 is equal to pi by 4 into D1 square 0.2 square. Okay. We get 1.114 meter per second. Then we need to find out the V2 value. V2 is equal to Q by A2. Q is given as 0.035 divided by pi by 4 into D1 is given as 0.1. So 0.1 square. When we multiply, so when multiplying we get 4.456 meter per second. We get the V1 value and also V2 value. Now we can apply the Bernoulli's equation. That is, P1 by rho g plus V1 squared by 2g plus Z1 is equal to P2 by rho g plus V2 squared by 2g plus Z2. So P1 is 39.24 into 10 to the power of 4 divided by 1000 into 9.81 plus V1 value 1.114 square divided by 2 into 9.81 plus Z1 value is given as 6 meter. Okay, 6 is equal to P2. We need to find out the P2 value. P2 by 1000 into 9.81 plus V2 value 4.456 square divided by 2 into 9.81 plus Z2 value is given as 4 meter. Okay, so Z2 value is 4. Okay, when we multiply this 39.24 into 10 to the power of 4 divided by 1000 into 9.81, we will get 40 plus 1.114 square divided by 2 into 9.81. We will get 0.0632 plus 6 is equal to P2 by 9810 plus 4.456 square divided by 2 into 9.81. 1.012 plus 4. You will add all this and you can bring this to this side. 40 we will get 46.0632 is equal to P2 by 9810 plus 5.012. You bring this value to this side. 46.0632 minus 5.013 is equal to P2 by 9810. So you get minus 5.012. 41.0512 is equal to P2 by 9810. P2 is equal to into 9810. You get 402.712 Newton per meter square. Here in the problem they are given the P1 value in Newton per centimeter square. So we are also converting this pressure value P2 value also by Newton per centimeter square. So we can divide this by 402.717 divided by 10 to the power of 4. So you get 40.2717 Newton per centimeter square. So this is the intensity of the pressure at section 2 is given as calculated as 40.2717 Newton per centimeter square. What they are given and what they are asking is a pipe of 400 millimeter dia carries water at a velocity of 25 meter per second. The pressure at the points A and B are given as 29.43 Newton per centimeter square and 22.563 Newton per centimeter square, while the datum head at A and B are 28 meter or 30 meter. Find the loss of head between A and B. Okay, so this is the question they are given. So first we can write that given data. So given data, diameter is given as D is equal to 400 millimeter, which is equal to 0.4 meter. Okay, so the velocity of water through which the pipe is carrying is V is equal to 25 meter per second. So the velocity will be the same for both the sections A and also the B. Okay, then the pressure at the point given as PA is equal to 29.43 Newton per centimeter square. So we can convert it into meter. So 29.43 into 10 to the power of 4 Newton per meter square. Pressure at A is 29.43 Newton per centimeter square converted into Newton per meter square. The same way PB is also given. PB is equal to 22.563 Newton per centimeter square. Okay, so 22.563 into 10 to the power of 4 Newton per meter square. Okay, then what are the data given? While the datum head at section A is A and B are given 28 meter and 30 meter. That is Z1 given as 28 meter and Z2 is equal to 30 meter. Okay, so now we apply Bernoulli'S equation. So there is here PA by rho G plus V1 squared by 2G plus Z1 is equal to PB by rho G plus V2 squared by 2G plus Z2 plus there may be a head loss which may be very lesser. Okay, so now we are asked to find out the head loss for the problem. Okay, so you can write PA is equal to 29.43 into 10 to the power of 4 divided by rho value is 1000 into 9.81 plus velocity is given as 25 meter per second plus 25 squared by 2 into 9.81 and Z1 value is given as 28 meter. This is given as 28 meter is equal to PB is 22.563 into 10 to the power of 4 Newton per meter square. 22.563 into 10 to the power of 4 divided by 1000 into 9.81 plus V1, V2 both are same. This velocity in the pipe which is carrying is same. So 25 into 9, divided by 2 into 9.81 and the data value is given as 30 meter plus 30 plus HL. Okay, so when we calculate this one is 30 plus 25 square divided by 2 into 9.81 31.855 plus 28 is equal to 22.563 into 10 to the power of 4 divided 1000 into 9.81. You get 23 plus 25 square divided by the same value we will get. 31.855 plus 30 plus HL. Is equal to 23 plus 31.855 plus 30. 84.855 plus HL. Then HL is equal to 89.855 minus 84.855, which is equal to 5 meter. Okay, so the head loss which occurs between the sections and A and B is equal to A and B is equal to 5 meter. Very clear? Today we are going to see the problem related to Bernoulli'S equation. The given problem is a pipe through which water is flowing is having a diameter of 10 cm and 20 cm and 10 cm respectively. Okay, so the given data is D1 is equal to 20 cm, which is equal to 0.2 meter. Okay, the D2 given it as D2 is equal to 10 centimeter, which is equal to 0.1 meter. Okay, so the water is flowing through, the pipe is flowing through water. It is having a diameter of 20 and 10 centimeter. The velocity of the section at 1 is 4 meter per second. That is, V1 is given as 4 meter per second. Okay, what we are asked to find out is, we need to find out the velocity head at section 1 and section 2 and also the rate of discharge. Okay, so we need to find out the velocity head at section 1 and also the velocity head at section 2, and the third one is rate of discharge Q. So these are the things we need to find out for this problem. So what we first we need to find out the velocity head at section 1. As per the Bernoulli'S equation, we need it. That is, velocity head is equal to V1 squared by 2G. We know the V1 value as 4. So we need 4 squared by 2 into 9.81. Okay. So when we multiply this one, so the velocity head at section 1 is 0.815 meter per second. Okay, so the velocity head at section 1 will be 0.815 meter per second. Okay, then we need to find out the velocity head at section 2. Okay, so in this case, in the problem they have already given that velocity V1 is given, so we directly calculate that, use the formula V1 squared by 2G. But in the case of velocity head at section 2, we doesn't know that V2 value. So for that purpose, what we are doing is, we are applying the continuity equation. Okay, so the continuity equation will be A1 V1 is equal to A2 we need to find out the velocity v2. Then we can find out the velocity head at section 2. Okay, so find the a1. That is 5 by 4 d square 5 by 4 into, what is the d1 value given? 0.2 square. Okay. So you get a1 is equal to 0.0314 meter square. Okay, so a1 is equal to pi by 4 d square, d1 is given as 0.2 meter. So we get the a1 value. Then we need to find out the a2. a2 is equal to pi by 4 into d2 square, pi by 4 into d2 value is given as 0.1 meter. Okay, so 0.1 square. We'll get 7.85 into 10 to the power of minus 3 meter square. Okay, so we can find out that V2 is equal to A1 given it as, we calculate as 0.0314 into V2 is, V1 is 4 divided by 7.85 into 10 to the power of minus 3. So calculate 3. 1.6 into 10 to the power of minus 5 meter second. Okay, so velocity head is equal to v2 squared by 2g is equal to 1.6 into 10 to the power of minus 5 divided by 2 into 9.81. So we find out the A2 value. Now we can calculate V2 is equal to 0.0314 into V1 value is 4, it is already given, and A2 is 7.85 into 10 to the power of minus 3. When we calculate this, 0.0314 into 4 divided by 7.85 into 10 to the power of minus 3. We will get 16 meter per second. Okay, so we find out the velocity Q value. Then we can apply this V2 value and find out the velocity head at section 2. Velocity head at section 2 is equal to V2 squared by 2g. So V2 we find out it as 16 squared by 2 into 9.81. Which is equal to 13.04 meter per second. Sorry. Meter per second. Okay, so we find out the velocity gate at section 1, velocity gate at section 2. Then third one we need to find out the rate of discharge. Okay, third one is we need to find out the rate of discharge. So to find out the rate of discharge, Q, we know that Q is equal to AB. So in this case we can use A1 V1 or A2 V2. So we can use any one of these. Now I am taking this V1 and A1, which is section 1, velocity gain at section 2, and also the rate of discharge.